Hello students. So let's continue with the problems on areas related to circles. So the first question, find the area of the shaded region as shown on the figure. If PQ is 24 centimeter, PR is 7 centimeter and O is the center of the circle. So very clearly they have given O is the center of the circle. If O is the center of the circle, it implies QR is diameter of the circle. Okay. QR is diameter of circle. If QR is diameter of the circle, then whenever you draw a diameter, you can divide the circle into two equal parts, isn't it? So the bottom part and the top part are two semicircles, isn't it? So whenever you draw a diameter, you get a semicircle. Therefore, we have learned that angle in a semicircle is 90 degrees. So therefore, this angle will become 90 degrees because this part of the circle is what? Semicircle, isn't it? Because whenever you draw a diameter, we get semicircle. Now angle QPR is equal to 90 degrees. The reason is because angle in semicircle is 90 degrees. Okay. Now we have to find the area of the shaded region. What we'll do is, let's take only the semicircle. Okay, the bottom part. What we have got Q R, and here is the center, and here we have got a semicircle, isn't it? Something like this. Now here in between we have got a point P. Let's join P and Q. Okay, now this is the shaded region, right? Whatever we are shading it, that is the required region. Now what we'll do is, we'll find the area of the semicircle. When I say area of the semicircle, we get this entire thing that I'm shading now. We get this entire thing, right? This entire thing is semicircle. The region inside the semicircle. Okay? We get entire thing. In this entire thing, okay, this is area of the semicircle. In this entire thing, what is not required? Let me color it in red. Okay, what is not required? Okay, so if you observe, this triangle is not required, isn't it? We don't require this triangle. So if you subtract this from the entire semicircle, okay, we get it, isn't it? So let me repeat it again. See, when we find area of semicircle, we get the entire area, isn't it? In that, what is not required? The triangle area is not required. Okay. So area of shaded region, that will be equal to area of semicircle minus area of triangle. What is the triangle? PQR. Area of triangle PQR. And remember, the angle here is 90 degrees. Okay. Now we know that area of semicircle is given by the formula half pi r square minus an area of triangle PQR. You can use the formula half into base into height. Here you can take RP as the base. If you take RP as the base, QP will become the height. Whichever side you take it as the base, for that side you should have the perpendicular from the opposite vertex. So if RP is the base, the opposite vertex is Q. From Q you have got perpendicular, that is QP. Okay, that will be acting as height. Now the problem here is, they have given you the value of RP and QR, but remember they have not given the radius of the circle, isn't it? So the radius of the circle is not given. If radius of the circle is not given, then we won't be able to find the area of the semicircle. So we have to find radius. How to find radius? Let me do it here. Now remember, QR is the diameter, right? Now PQ, PR and QP. Okay, these are the three sides of the right angle triangle. So in that we know the two sides, that is QP is 24. This is 24 centimeter and this is 7 centimeter. So using Pythagoras theorem, we can find it. So in triangle PQR, angle P is 90 degree. Okay, therefore using Pythagoras theorem, if we use Pythagoras theorem, the square of hypotenuse, that is QR square, that will be equal to PQ square or QP square plus PR square. PQ is 24, 24 square plus 7 square. 24 square is 576, 7 square is 49. So 576 plus 49 is 625. Therefore, QR square is equal to 625, which implies QR is square root of 625, which becomes 25 centimeter. So what is QR? QR is diameter, right? If QR is diameter, so diameter is 25, D is equal to 25 centimeter, which implies R will become 25 by 2 centimeters, isn't it? So let's substitute that here. So half as it is. Pi value is not given, so let's take it as 22 by 7. And R square, so it will become 25 by 2 the whole square minus 1 by 2. RP into QP. RP is nothing but PR, whose value is 7. QP is how much? 24. QP is nothing but PQ. Okay. So here 2 ones are 2 11s are. So we are left with, let me scroll a bit down. So 11 by 7. 25 square is 625. 2 square is 4 minus 1. Here you can 2 ones are 2 12s are. So we are left with 7 into 12. Okay. So 11 into 625. So it becomes 5, 7, 8, 6, 6, 8, 7, 5 by 28 minus 12 sevens are 84. Okay. So you can divide this 6, 8, 7, 5 by 28. How much ever you get, subtract it with 84. Let me do it. 6, 8, 7, 5 divided by 28. That will become 245. 245.554 minus 84. Okay, minus 84. So the final answer, we get it as 161.54 centimeter square. Okay, so that will be the required area. So here there are a few things that we have to observe. First, as soon as we get this circle and we have the diameter, so we get to know it's a semicircle. So angle in semicircle is 90 degree. So we got to know that PQR is a right angle triangle. Once we got to know it's a right angle triangle, then we can use Pythagoras theorem. So using Pythagoras theorem, we got QR, which is the diameter. So divide by 2, you get radius. Then substituting in the values, substituting in the formula, we get the answer. So next question. Coming to the next one. Find the area of the shaded region if the radii of two concentric circles with center are 7 centimeter and 14 centimeter. Let's take the capital R to be 14 centimeter and the small r to be 7 centimeter. Okay, an angle AOC is given as 40 degree. Let me take only the required shaded part. So if you observe here, A, B, C, D. Now for time being, just this is 40 degrees. Let's just forget this BD. Now what is this figure? It's actually a sector, right? This is a complete sector. And if you forget this AC, what is OBD? That is also sector. Actually, there are two sectors here. Okay. One is the bigger one, that is OACO sector, and the other one OBDO. Okay, there are two sectors. Now, what is required? We require only this area. So let's find the bigger area. In that bigger area, that is in the bigger sector, we'll subtract the smaller sector. If you subtract the smaller sector, easily we'll get it. Okay. So area of the shaded region, area of shaded region is equal to area of the bigger sector, that is area of sector. What is the name of the sector? OACO minus area of sector OBDO. Area of sector is given by the formula theta by 360 degree into pi. This is bigger sector, so capital R, pi capital R square minus theta by 360 degree pi small r square. Remember, before substituting, you should always take common. So here theta by 360 degree, pi is common. What is left out? Capital R square minus small r square. Now let's substitute the value of theta. The value of theta is 40. So 40 degrees by 360, pi value is 22 by 7, capital R is 14 square minus small r is 7 square. Okay, so let me solve it here. So 40, 0 gets cancelled, 4 ones are 4 nines are, so it will become 1 by 9 into 22 by 7. Here inside the bracket you can use a plus b into a minus b, so it will become 14 plus 7 into 14 minus 7, a plus b into a minus b. Okay, so 14 plus 7 is 21, so 1 by 9 into 22 by 7 into 21 into 14 minus 7 is 7, 7 gets cancelled, 3 threes are 3 sevens are, so it becomes 22 into 7 is 154, 22 into 7 is 154 divided by 3, so many centimeters square. Okay, that's the required area. Let's get into the next question. Again, we have to find the area of the shaded region. Now ABCD is a square. Okay, ABCD is a square, and if you observe, they have given that APD and BPC are two semicircles. So what we are going to do here is let's find, see what we are going to do is let's find the area of the square. Okay, that is the complete square. Let's find the area of the square. Okay, this is the area of the square which I have shaded completely. In that, okay, if you subtract, or let me do it like this, let me color only the semicircles, that will be fine. Okay, only the semicircles. Let's understand like this. Okay, so I've colored this semicircle in green color. Let me also color the other semicircle in green color. Okay, now very clearly from the figure you can easily get to know that from the figure there are two green regions, right? Two green regions, that is two semicircles, two semicircles, two semicircles plus the blue region. Okay, the blue region. Okay, if you add both you will get the area of square, right? You get the square, but what is required? You need blue region, so you don't need the semicircle, so send it the other side. So blue region will be what? The square minus two semicircles, isn't it? So the area of the shaded region, so we have understood that area of shaded region, that is the one which is shaded in blue color, area of shaded region. Okay, that will be equal to, let me erase this, area of shaded region, that will be equal to, let me write it properly, area of shaded region, that will be equal to the entire area of the square, area of square. In that, what we have to subtract? 2 times area of semicircles, because there are two semicircles and both are equal, right? So that's why we have taken. Now what is area of square? Side into side, that is the area of the square, minus 2, area of semicircle is half pi r square. Now remember, they have not given the radius of the semicircle, but this side of the square is acting as the diameter, right? For the semicircle it is acting as the diameter, so diameter is indirectly given as 14 centimeter, which implies r will become 7 centimeter, because they have given this, the length of the sides of the square are 14 centimeter. This 14 centimeter is actually acting as the diameter, so radius will become 7. So here 2 and 2 gets cancelled. So side is 14. So 14 into 14 minus pi is 22 by 7 into 7 square. So 7 into 7. So 7 gets cancelled. 14 into 14 is 196 minus 22 into 7 is 154. So if you subtract it, you get 42 centimeter square. That's the required area. So let's get into the next problem. Okay. So in the next problem, again, area of the shaded region. What is given? We have got a circle of radius 6 centimeter. So they have given circle of radius 6 centimeter. And there is an equilateral triangle whose side is 12 centimeter. Side of equilateral triangle is equal to how much? 12 centimeter. Here we have to find the area of the shaded region. Area of shaded region. Now, if you observe carefully, the equilateral triangle, the entire triangle is shaded, right? So we have to find the area of the equilateral triangle. Area of equilateral triangle. Okay. Then see, this is area of equilateral triangle. We have found this. Along with that, what else is shaded? This part. Okay, and the top part. How does it look like? See, this is how it looks, right? Now this is what? This is a sector, right? Major sector. See, the bottom one will be a minor sector. Okay, but we are not interested in it because that is already found inside the triangle. Okay, so we want this area. How do we find it? Area of the major sector. Okay, using area of the major sector formula. So plus area of major sector. Now what is area of an equilateral triangle? Root 3 by 4 into side square plus area of major sector 360 degree minus theta by 360 degree into pi r square. Now remember the theta is here. Okay, what is the theta? It is 60 degree. Why? Because OAB is an equilateral triangle. All the angles will be how much? 60 degree, right? So theta is equal to 60 degrees. So root 3 by 4, side of the equilateral triangle is 12 square. So we can write it as 12 into 12 plus 360 minus 60 divided by 360 pi r square. Pi is 22 by 7 and radius of the circle is 6 square, isn't it? So therefore it becomes, you can cancel here, 4 ones are 4 threes are. So root 3 into 3 into 12 plus 360 minus 60 is 300 divided by 360 degree into 22 by 7 into 36. So here 0 gets cancelled. 36 ones are gets cancelled. So we are left with 12 into 3 is 36. 36 root 3 plus we are left again 30 into 22 by 7. Okay. So 36 root 3 plus 3 2s are 6, 3 2s are 6, 660 by 7. Okay. So 36 is with the, 36 root 3 is an irrational. 660 by 7 is a rational. So we are not supposed, we cannot add it. So let's keep it as it is. So many centimeter square. So the SI unit was in centimeters. So many centimeters square. Let's come to the next one. Okay. Now again the same logic. We'll be finding. We have to find the area of the shaded region, isn't it? So first let's write the formula. Okay. Area of shaded region. That will be equal to, what we'll do is we'll find the area of the square. Okay. We'll find area of the square ABCD. In that, whichever is not required, let's subtract it. If you observe, there is a circle inside which is not required. It is not shaded. So let's subtract it. So area of circle, okay, minus, if you observe at the edges, what are these? These are actually quadrants because they are looking like a sector and the angle is 90 degrees. Therefore, they are quadrants. How many quadrants are there? 4 quadrants. So 4 into area of quadrants. Okay, so area of square is given by what formula? Side into side minus area of circle is pi r square. Okay, minus 4 times area of quadrant is 1 by 4 pi. See, remember, you cannot write it as r square. See, the circle here and the quadrant, if they are having the same radius, then you can use the same r in both the places. Now, if you read the question, the from each corner of square of side 4 centimeter. Okay, the square side is 4 centimeter. They have given it. Let's take this as 4 centimeter. Okay, a quadrant of circle of radius 1 centimeter. So the radius of the quadrant is 1 centimeter, and also a circle of diameter 2 centimeter. So the circle which is inside, whose diameter is 2 centimeter, which implies radius is what? 1 centimeter. So the radius of the circle and the radius of the quadrant are same. Therefore, we can use same r. Okay. So I've used same r. So side into side. What is the side of the square? 4. So 4 into 4 minus pi value is 22 by 7. R square. What is r? 1 square. Here 4 and 4 gets cancelled. Again, pi is 22 by 7. R is 1 square. So 4 into 4 is 16 minus 22 by 7 minus 22 by 7. So it becomes 16 minus 44 by 7. Minus 22 gives you minus 44. So here you can take LCM, or you can divide 44 by 7. So if we divide 44 by 7, we get 6.28. 16 minus 6.28. Okay. 16 minus 6.28, we get it as 9.72 something. So 9.72 centimeter square. That's the required area. So let's get into the next question in the next video. Okay, we'll do we have solved 5 problems in this video. Let's continue with the next problem in the next video. Thank you, students.